Okay, first let's look at the two pieces of given information because they both lead to completely separate things for you. This one says that CB is parallel to ED, which is already marked. So that side is parallel to that side. And of course we have transversals coming through here like this and like that. So you're going to have alternate interior. Let's go ahead and see where that leads. That means angle B and angle E are going to be alternate interior, so they're congruent. And that also means that C and D are congruent because they're alternate interior. Now that I have two angles, I don't even need the vertical in the middle, although you could use it instead of one of the other angles if you wanted to. The other piece of information, well, first let's write down this. We said angle C is congruent to angle D because alternate interior angles are congruent. And you can pair up E and B with that too if you want. You can just put a quote saying it's the same thing. As long as what you write makes sense, you don't have to write too much stuff, okay? Now the other piece of given information was that A was the midpoint of CD. That's going to lead to something completely different. A is the midpoint of CD and only C. It doesn't say anything about E and B. So that means that that side is congruent to that side. So CA is congruent to AD. So CA is congruent to AD. And that is because a midpoint divides a segment into two congruent parts. So now let's take a look at, see if we have the three strikes that we need. We had a pair of angles here, we had a pair of angles here, and then we had a pair of sides there. Again, AAS does not mean it's in that order. Let's go up to the picture and take a look. And in this case, we do in fact have angle, angle, side. So it was by chance in order, but not because it was written in order there. So the final line of the proof, once you have your three strikes, is to copy over the prove line. Triangle EAD is congruent to triangle BAC, and that's because angle, angle, side is congruent to angle, angle, side. Okay, I think number 4 here is probably the most complicated one we've done so far. It's really not that bad, but compared to the other ones, there's obviously 3 pieces of given information, and they each lead to something different. There's 2 sets of parallel lines. So if you look at the first 2 givens, AB is parallel to CD, and BC is parallel to DE. So I have all the givens written, but let's go up and extend these lines a little bit. Okay, so I extended the 2 purple parallel lines and the 2 pink parallel lines because each set was parallel to each other. And then I went ahead and numbered the angles that I think are going to be involved here, and you can number them the same way. I have angle 1 there, 2 there, 3 is here, and only I know that that's going to be involved right now, so just trust me. That's 4, and that's 5, okay? Now, angle 2 is actually congruent to angle 3 because of alternate interior angles. So I know angle 3 is not part of either triangle, but let's write down angle 2 is congruent to angle 3. And the reason is alternate interior angles are congruent. Now, angle 3 is congruent to angle 5 because they're also alternate interior angles. So I'm going to add that to the mix. Angle 3 is congruent to angle 5 for exactly the same reason. Alternate interior angles are congruent. Now, if angle 2 is congruent to angle 3, and then angle 3 is congruent to angle 5, that must mean, through logic, that angle 2 must be the same as angle 5, because they're both congruent to angle 3, so they must be congruent to each other. And that is a new word called the transitive property. Trans is a term in Latin that means across, so to change from one thing to another through something else. So because 2 is the same as 3, and 3 is the same as 5, then 2 must be the same as 5. Transitive property. Okay, that was a lot of work just to prove 2 and 5 congruent, but now we have a pair of angles. The other one's a little bit easier. If you look at this transversal here, and you have these two parallel lines here, angle 1 and angle 4 are corresponding angles, and they are congruent. So the next one, we can say angle 1 is congruent to angle 4 because corresponding angles are congruent. So far, we have a pair of angles and a pair of angles. We're looking for one more piece. And that's the other piece of given information that we had way up here before. So because C was the midpoint of AE, even though this is somewhat out of order, we haven't talked about line 3 in a long time. If C is the midpoint of AE, that means that that side and that side are congruent. AC and CE are congruent. AC is congruent to CE because a midpoint divides a segment into two congruent parts or segments. Anything that's similar to that will be fine. And that is the third part that we needed. So I don't know that it's AAS in that order. I know that I have 3, so I'm ready to go. Let's go look at the picture and see what we have here. We have an angle, and a side. So it is, in fact, again, angle, angle, side in that order. So the last line of the proof is to copy over the prove line from up here, and we decided on the picture above that it was angle, angle, side. So a 9-step proof involving something new called the transitive property. So we'll talk about that more later, but that was the most intense proof we've had so far. The first thing you should do when you have parallel lines in any problem in geometry is just extend those parallel lines beyond the corners. So all I did here was take a straight edge and go beyond the corners of every single one of those 5 different lines. The 2 parallel horizontal, the 2 parallel that were more slanted, and then that one strange diagonal that goes through A and C. So because there's 2 different pairs of parallel lines, we're going to focus on one pair at a time. I'll first look at this and this, kind of the top and the bottom, and still that transversal here. I'm seeing angle 2 and angle 4 as alternate interior angles, and those are congruent. So angle 2 is congruent to angle 4 because alternate interior angles are congruent. And there's a congruent sign there, so I have a pair of angles right away. Now I have 2 different parallel lines. I have this one and this one. And they have a transversal, same one, but that makes angle 3 and angle 1 congruent. So angle 3 is congruent to angle 1 for the same reason. Alternate interior angles are congruent. There's another set of angles. They were from 2 different sets of parallel lines, but they were still alternate interior angles each. Okay, so there's our 2 strikes. We're just looking for our third part. And because we have 2 angles, we know it has to be a side, because we know AAA is a postulate. So we're looking for a side, and if you haven't already noticed, they share the side right in the middle. AC is in both that triangle and that triangle. So because they share AC, we haven't used reflexive in a while, but AC is congruent to AC because of the reflexive property. And that is my third part that I was looking for. There's my S. I don't know that it's AAS, so I have to go check the picture. And let's see what I have here. It's not this time. It's angle, side, angle. The angle in the corner, then the reflexive side, and then the other angle. So now that I'm done, I can finish the proof by writing the proof line down. Triangle ABC is congruent to triangle CDA because of angle, side, angle being congruent to angle, side, angle. And we're done. Okay, so number 6 now. I have 3 pieces of given information. I wrote them all as my first 3 lines of the proof. 2 sets of parallel lines and 1 set of congruent parts. In fact, the congruent side, I can already go down and put an S next to that because they already gave it to me. But for now, let's look at the parallel lines DE and CB. I extended just those for a minute, and then I extended the transversal. And if you look, that angle E and that angle B are far away from each other, but they're really just alternate interior angles because there's 2 parallel lines. There's the transversal. There's a lot of distracting stuff going on, but that angle is alternate interior with that angle. So angle E is congruent to angle B because alternate interior angles are congruent, and that gives me a pair of angles. Okay, I erased all of the parallel lines I had in the last section, and I redrew them with the other set of parallel lines, which is DG and AC, because it was getting too distracting. I know you might not be able to do that, but I can, so this should help. So those 2 parallel lines now, looking at this angle and this angle, those are just alternate exterior angles from the beginning of the year. Alternate exterior are also congruent. So angle G and angle A are congruent because alternate exterior angles are congruent. Alternate exterior angles are congruent. And that looks like it's going to be my third strike. So I have 2 angles and a side. Let's go check the order. So it's really congested here, but there is an angle, a side, and an angle right in a row. Same thing on the other one. Angle, side, angle, all in that one little section. So the final proof line is triangle EDG is congruent to triangle BCA because of angle, side, angle being congruent to angle, side, angle. Okay, let me know whatever questions you had on that, but it should be completed because you watched the screencast and everything should be filled in completely for tomorrow, Wednesday, and now assignment 32. If you go to Google Classroom, it looks a little bit different on your screen than it does here, but if you notice, there's a link at the bottom somewhere that says Congruence Proof Questions, Problematic. This is your assignment to do tonight. It can be done completely on the Chromebook. You click on this link, and it will open up what looks to be like a quiz. And I believe there are about 10 questions that are multiple choice. It will grade you automatically once you type in your name right here. And when your name is typed in, to get full credit, make sure you answer the questions and take your time. Don't just click around. Make sure you're looking at the right answer because you will get a grade. See you on Wednesday.